So we want to take a look at applying these linear inequalities to some more realistic applications. So what we have to take a look at is how are inequalities written in words so that we can translate them into an inequality in like a math inequality. So when we say at least 20, you're saying 20 or more. So you're saying some value that's greater than or equal to 20. And we just use x for some value. At most 20, that would be 20 or less. So x is less than or equal to 20. More than 20, that's values that are greater than 20. Less than 20, that's values that are less than 20. So we're going to stick to kind of the same framework that we had for regular linear equations, which is writing these guys in a y equals mx plus b format, except this time I'm going to flip this around. I'm going to have my total on the right-hand side, or my y. So I'm actually going to have this as mx plus b equals y. It's the same thing, but having that y on the right-hand side helps us figure out the direction of our inequality just a little bit better. It's also nice to solve and have your x on the left. So what we want to piece out are the different parts of this. So m in a slope-intercept form is typically our slope, or we often refer to it as our rate of change. Rate of change. So this is something in the problem that's going to be changing with respect to our variable x. So this guy is our variable, or we sometimes call it our unknown. So it's something that the problem is saying, hey, go find this. And typically a rate of change will be, something you're familiar with is maybe you make $9 per hour. So if you had 1 hour, your unknown, if it was 1 hour, then you'd make $9. If it was 2, then you'd make 18. If it was 3, and so on and so forth. Okay, so we have a rate of change being multiplied by our unknowns. That rate of change is changing with respect to that unknown value. And then last we have this b. This is our constant value, right? Our constant, or we often think of it as a starting value. So a constant or a starting value. So it's our y-intercept. It's where we start. So a lot of times we'll see this with respect to, say, like an electrician or a plumber. They're going to charge you a flat rate fee to show up at your house. Maybe it's $50, maybe it's $100, but regardless of if they stay there for 5 minutes or 5 hours, they're saying, hey, it's $100 for me to just show up. And then they add the rate of change on top of that. So it's $100 to just show up at your house, and then it's $50 every hour thereafter. And then our y here is typically our total. So we're gonna really work within those bounds and try to fit everything that's happening in here into that. Okay, so for the first one, I'm just gonna write this as a reference point. So mx plus b equals y. Except that equals, how about I instead put like a little circle there? Because that's gonna be an inequality, because we're describing an inequality, not an equals at this point. Okay, so Stan has saved $2,500 towards buying a car. He wants to save at least, so maybe we should underline that or highlight it because that seems like one of those inequality words, at least $8,000 to purchase the car 14 months from now. How much does he have to save per month to reach his goal? Okay, so let's piece together a couple of bits here. Stan has saved $25,000 towards buying a car. This is money that Stan already has in the bank, right? He is starting with that amount in the bank. So that's going to be our B value, our starting value, okay? He wants to save at least $8,000 to purchase a car 14 months from now. So this 8,000, that's what he wants to end up with. That's what he needs at the end to purchase his car. So that's going to be our Y, or the total amount that we are looking for. Okay. One thing we can use to try to find what our X is look in the problem for where it says per. He wants to save money per month. Per is often something we use in a problem like this to indicate multiplication, which is happening in between the M and the X there. We're multiplying that rate of change times X, okay? So we're looking at saying, okay, 14 months times how much per month, all right? So this 14 is gonna be our M. This is a little bit of an odd M. It doesn't work super well with the rate of change analogy, but we do want to think about multiplication here. Okay, so now we just have to substitute these things into our equation, all right, and figure out our inequality, right? So he has 14 months times however much he is saving each month. We don't know what that is. That's what we need to figure out. Plus, he already started with $2,500. He wants to end up a total of 8,000. Okay, so we need to figure out what inequality we need. So if we look at least, and we look at our words up here, at least is the greater than or equal to, right? Greater than or equal to. But we want to logic out why that is as well. So this section on the right is describing how much Stan is saving. So this is the description of what is happening to his bank account, what money is going in, what money was already there. 8,000 is describing what that car salesman is going to ask him for. His bank account dollar amount needs to be larger or equal to the amount that that car salesman is going to ask him for. So that's why we're using the greater than or equal to. Now at this point, we just need to go ahead and solve this inequality. All right, so we're going to take 8,000 minus 2,500, right? And we're going to get 14x is greater than or equal to 5,500. Then we'll divide both sides by 14, and we'll get that x needs to be greater than or equal to 392.86, and I'm going to round there. Now I rounded to the hundredths place because we're talking about money, right? We're talking about money. So let's answer this question. How much does he have to save it per month? Well, Stan has to save at least $392.86 every month in order to reach his goal. All right, let's do a couple more of these. Okay, Julie makes $6.50 an hour plus tips. So an hour, per hour, we use those words frequently. So this would be our rate of change, our M, right? Something per hour. So 650 times the number of hours she works. She made $98.40 in tips last week and said she made more than $220 total for the week, right? An inequality. So this is the amount of money we already know she made. This is what we're starting with. We already know that. And then we know that her total over here was 220. Okay. And we also know that she is saying she made more than that. So let's go ahead and write this down. She makes $6.50 every hour, and X is representing our unknown number of hours. Plus, she made $98.40 in tips. Now, we know that that is going to be more than, greater than, $220. Okay, so now we have our equation. So now we can solve. So we want to subtract 98.4 from both sides. And we're going to get that 6.5x is greater than 121.6. Now we can divide both sides by 6.5. And we'll get the x is greater than about 18.7 when we do some rounding. Now, that x is representing hours. We said x was number of hours that she's going to work. It isn't common for your employer to want to pay you for 0.7 of an hour. Sometimes they'll do to the half hour, but typically we're just going to round to the nearest whole hour here. So we're going to say that Julie needs to work at least, excuse me, I think I started writing more than, at least 19 hours. So let's just check that that makes sense. So let's just plug 19 hours into our equation here real quick as a check. So if she makes $6.50 per hour and she works 19 hours, let's multiply that by 19. Plus, she knows she already made $98.40 in tips. So let's go ahead and see what happens when we calculate that. So you're just going to take 6.5 times 19 plus those tips, 98.4, and she would then make $22 or $221.90. That is, in fact, greater than 220, so we know we went ahead and solved that correctly. She could also work 20 hours, 21, and so on and so forth, and she would still make more than $220. Okay, so McKenna has two dogs, Sadie and Nika. She knows that Nika eats 14 pounds over a 30-day month, 14 pounds of food over a 30-day month. Okay, and she has at most 40 pounds of total food for the dogs next month. At most, how much food can she feed Sadie each day over this 30-day month? Okay, so we know a total. That's pretty clear. Okay, but we need to figure out our M. So let's look for something in here that might clue us into what we're multiplying. So we know we have 30 days, and we know we need to multiply that by how much Sadie eats each day. So feeding Sadie each day. So our unknown here is going to be how much can we feed Sadie? And then we're going to multiply that by this 30-day time period. So this 30 day is actually going to be our M in this case. And then we simply need a starting value. Well, we started knowing that the other dog here has already eaten 14 pounds. So let's get this set up. 30 days times an unknown amount that Sadie is eating each day, plus our second dog already ate 14 pounds. She has a total of 40 pounds. Now, the right-hand side describes how many pounds the dogs are eating. The left-hand, or right, or excuse me, that was the left-hand side. The right-hand side describes how many pounds she has to feed them. Well, the dogs have to eat less than or equal to the amount of food that McKenna has available. Okay, she's not going out and buying more food. We have to stay under or exactly at that 40 pounds. So let's just solve this. We're going to take 40 minus 14. So we'll have 30x is less than or equal to 26. We'll go ahead and divide 40 or divide each side by 30. We'll get x is less than or equal to 0.87 when we round. So we can go ahead and just leave it at that. A scale would be able to measure 0.87 of a pound. So we can say that Sadie can eat at most, right? So she can only eat up to that. She can't eat more than that because otherwise we'd be going over that 40-pound limit. So she can eat at most 0.87 pounds, which is shortened to LBS, per day. Okay, last problem. Terry has two test grades of 83% and 91% and a third test coming up. He wants an average, so there's an important word, of at least 90% on the three tests. What's the lowest test score to the nearest percent that he can get on the third test to reach his goal? Okay, so this one's a little bit different because we're talking about an average. For an average, we take the sum of the numbers divided by how many numbers there are. So that's just kind of shorthand there. So if we're looking at finding an average of these three test grades, one of them we don't know. So we're going to call this third test X. So he got an 83%, he got a 91%, and he has an unknown test. To average them, we divide it by 3, because that's how many tests we took. Now, Terry says he wants at least a 90% in the course. So that's going to be his total. And we want his 3 tests to average out to greater than or equal to that 90%. All right, so let's go ahead and solve this. So I'm going to first simplify that numerator by combining like terms, 83 plus 91. So we're going to get 174 plus x divided by 3 has to be greater than or equal to 90. Okay, so now we can solve. So we can multiply both sides by 3, cancel to 1 on the left. 174 plus x needs to be greater than or equal to 270. All right, and then we can subtract 174 from both sides. Ooh, I wrote that a little strange. Minus 174. We get that x, or his third test grade, needs to be greater than or equal to a 96. So that tells us that Terry must get a 96% or better on his third test if he wants to get a 90% or greater overall in the course.